Hello, welcome to the course of IPv6. So today we are going to discuss about the IPv6 protocol structure. So in this class we are going to discuss about the topics like the IPv6 address structure, the rules of address notation and the packet format. So starting with the first, that is the address structure. So how to write the IPv6 addresses. So as the IPv6 addresses are of 128 bit long, so it is divided into 8 16 bits block. So each block is then converted into 4 digits. So it is represented by hexadecimal number represented by the colon symbol or separated by the colon symbol. So this IPv6 addressing structure is designed in RFC 4291. So let's discuss the representation of this. So for example, here I have taken the example of the IPv6 address that is represented in binary format. So here the binary format is divided into 8 16 bits block. So here you can see that there are 8 blocks, 1 2 3, this one is the 4th, 5th, 6, 7 and 8. So these are the 8 blocks, and in each 8 block we have 16 bits. So these 16 bits represents this particular IPv6 address that is represented in hexadecimal format. So each block is then converted into hexadecimal and separated by the symbol. So it represents the 2001 colon 0000 colon 3238 colon DFE1 colon 0063 colon 0000 colon and 0000 colon then FEFB. So this is the IPv6 address that is 128 bit long, and this is the binary notation, and this here this one is the hexadecimal notation. Coming to the next part, how to write these IPv6 addresses. So IPv6 addresses has some rules to shorten these addresses. So discard some zeros or to add some information. So like the first one rule is discard leading zero. So if we discard the leading zeros, so like here I have represented leading zeros of a section can be omitted. Only leading zeros can be dropped, no trailing zeros, such as in block 5. So here we have to only drop the leading zeros. Like in block 5, we have represented these zeros 0063, and here I have in next we can drop these zeros that are the leading zeros, but we can't drop the zeros that are coming in between or that are coming after that are the trailing zeros. So the first rule is discards the leading zeros to make this IPv6 address short. Next rule is replace consecutive 0. So to replace this 0, if 2 or more blocks contain the series of zeros, then omit them all and replace it with the double colon sign, and such as in this 6th and 7th block. So here in this IP addresses, here we have represent these series of zeros that come in between the IPv6 address. So we can omit it and it represented with this double colon. So this will make this IPv6 address more short. Next rule is the consecutive block of zeros can be replaced only once. So if there are still block of zeros in the address, they can be replaced by a single zero, such as in the second block. So like here we have represented that the series of blocks are converted into the colon to make this IP6 address short. So if more zeros are come in between the address, we can't use the colon again, double colon again. Here we have to represent this zero by the single zero. So these are the rules to represent the IPv6 address. Next is the how to represent the IPv6 and IPv4 address together, as our network has a combination of these two addresses. So how to represent these two addresses together. So the format of IPv6 addresses is we can represent the IPv6 address in the Y format, and the X represents the IPv4 addresses. So it can be written as 2001 colon db8 colon 3333 colon 4444 colon 5555:6666 and then the IPv4 address, that is 192.168.1.4. So here the IPv6 represents in the segments, and here it represented in the hexadecimal number from 0 to FFFF. And where IPv4 addresses are represented in octet format and the decimal number that are ranging from 0 to 255. So in IPv6 it are separated by the colon, and IPv4 addresses are separated by the period or the dot sign. Next is representing these addresses together. So IP address, I want to represent the IP address 192.168.0.2 into this combination of address. So method 1, I can write it as 0:0:0:0:0, then 192.168.0.2. The another method is I can represent the double colon in front of this IPv4 address and then 192.168.0.2. Then the another method is hexadecimal representation, in which I convert this IPv4 address into the hexadecimal format. So it is represented as double colon CO8 colon 2. So this is the representation of the IPv4 and IPv6 address together. The next we are going to discuss about the structure of IPv6 packet. So the IPv6 packet is consists of IPv6 header, extension header, and the upper layer protocol data. So IPv6 header contain the information, the basic information like the source address, the destination address, the header length, etc. Whereas the extension header will contain the extension additional information like the hop by hop option, destination option, router header, etc. And here in upper layer protocol data, here the information of the user is added over here in this block, upper layer protocol data. Let's discuss about the IPv6 header. So the IPv6 header is consist of these particular fields like version, traffic class, flow label, payload length, next header, and it is of 32-bit long. So you can see from here the IPv6 headers is more complex than the IPv4 header, as IPv4 header consists of a number of fields. Here the number of fields are less. So let's discuss about these fields one by one. The first one is the version field, that is 4-bit long, and it is same as the IPv4, but it is represented by this bit sequence with 0, 1, 1, 0. So this particular version field will remain constant. The next part is traffic class. Traffic class is it of 8-bit long, and this field has the two values, that is DS and ECN. So here this field, these 6 most significant bits are used for differentiated service, and the remaining 2 bits are used for the ECN, that is explicit congestion notification. So these traffic class represent these 2 different bits. So DS classify packet, it is end up with 0 bit and it is a standard bit. If it is end up with the 1 bit, then it is a local or a experimental use. So ECN is representing the 2 part, that is congestion control traffic or no congestion control traffic. The next part is the flow label. Flow label is used for giving real-time application service and also used to detect the spoofed packet, and it is of 20-bit long. So the size of the next part is the payload length. So the payload length here represents a hop by hop extension header. So whenever a hop by hop extension header holds a jumbo payload option, then the length is set to 0. Here the jumbo payload is a user data field that exceeds the IPv4 limit of 65,535 octet is called the jumbo payload. So if it exceeds this, then we have to add the hop by hop extension, and here the length is set to 0, that is, and so this field is of 16-bit. The size of payload length is represented in octet by including extension headers. The next field is the next header field. So next header field specify the type of next header, and it is of 8-bit long. This field usually specify the transport layer protocol used by the packet payload. Next is hop limit. Hop limit is specify how many number of devices can be visited by a packet. This field replaces the time to live field in IPv4. So this particular field works same as the time to live field and IPv4, and it is of 8-bit long. So the value of this field decreased by 1 at each intermediate node visited by the packet. When the counter reaches 0, the packet is discarded. So in this way, this hop limit counts. Next is source address and the destination address field. Source address contains the IP address of the source node, that is the originator of the packet, and it is a 128-bit long. And destination address indicates the IP address of the node where we want to send our IPv4, IPv6 packet. So this is 128-bit long. So this is all about the IPv6 structure part. So thank you.